Assalamu alaikum. Welcome to the video series on past paper questions of O-level physics 5054. In this video we will discuss paper 1 questions related to the topic of waves. So our first question is question number 29 from May-June 20 variant 2. The question is that the diagram shows how the height above the ground of a rope transmitting a wave varies with distance from the source of vibrations at one instant in time. So we have a height on y-axis and distance on x-axis. And we have to find the amplitude of the wave. Now what is the amplitude? Amplitude is the distance of the wave from mean position to the crest or from mean position to the trough. So here we have the mean position here at 40 and the crest is at this mark. If you see, one small box is representing 2 centimeters. So we will count the boxes and then we will apply the scale to find the amplitude in centimeter. So these are 10 boxes and 1 2 3 4 5 6 7. So there are a total of 17 small boxes and one small box represents 2 centimeter. So we will multiply it with the 2 and it becomes 34 centimeter. So if you see the options, we have here 34 centimeter, option B. Okay ji, our next question is question number 26 from October-November 20 variant 1. An electromagnetic wave has a speed of 30 meter per has a speed of 3 into 10 to the power 8 meter per second and a wavelength of 10 centimeter. What is the frequency of the wave? So it is a simple question. We just have to apply the formula of the wave speed. V is equal to F into lambda. We are given here the speed, that is 3 into 10 raised to the power 8 meter per second. We have to find the frequency and the wavelength is 10 centimeter. Wavelength is 10 centimeter, so we have to convert it into meter first. So it will be 10 into 10 raised to the power minus 2. So frequency will be 3 into 10 raised to the power 8 divided by 10 into 10 raised to the power minus 2, or we can write it as 10 raised to the power minus 1. So it will become 3 into 10 raised to the power 8 minus 1, which will be equal to 3 into 10 raised to the power 9 hertz. So it is option D. Okay, our next question is question number 25 from May-June 19 variant 2. And this is one of the most difficult questions that appeared in the paper. The question says that a wave on water traveled towards a stationary boat. As the wave passes, the boat starts to move up and down and gains kinetic energy from the wave. Which property of the wave changes as the wave passes the boat? Okay, here is a wave, and as this wave passes the boat, this wave transfers energy to the boat. The boat gains kinetic energy from the wave. So the energy of the wave is transferred to the boat. Which property of the wave changes as the wave passes the boat? Now when the wave passes the boat and it transfers energy, its amplitude must change. Its frequency will remain the same, its speed will remain the same, and its wavelength will also remain the same. A very common mistake is to choose option number C, because it is gaining kinetic energy, and kinetic energy is related with the speed, but here kinetic energy is gained by the bot, and as a result the amplitude of the wave must be decreased. Okay, our next question is question number 22 from October November 19 variant 2. Which description defines the amplitude of a water wave in a ripple tank? Amplitude is the distance between the crest and the mean position, or between the trough and the mean position. So option A says half of the vertical distance between a trough and a peak. No, it seems, oh yes, half of the vertical distance. So it, if this is the wave and this is the mean position, this is the trough, this is the peak, the crest or the peak, and half of the distance. This distance will be equal to twice of the amplitude, so half of it will be equal to the amplitude. So A seems the correct option. But let's see another options. B is the horizontal distance between adjacent peaks. No, horizontal distance between adjacent peaks is the wavelength, not the amplitude. Okay, C. The horizontal distance between a trough and an adjacent peak. No. Between trough and adjacent peak, it will not be equal to the amplitude, because amplitude is the vertical distance. The vertical distance between a trough and a peak. No, the vertical distance between a trough and a peak is twice the amplitude, not the amplitude. So option A is the right answer. Okay, so our next question is question number 23 from October November 19 variant 2. Here are 4 statements about wave fronts, and which 2 statements are correct we have to find. First statement, wave fronts from a point source are straight lines. No, the wave fronts from a point source are not straight lines, these are circular. So first statement is not correct. Wave fronts from a point source are circular. Yes, point source, the wave fronts are circular. If we have a point source, the wave fronts will be like this. These are circular. So this statement is correct. Third statement is wave fronts are parallel to the direction of energy movement. No. If you see here, the energy movement is in this direction. So these are the perpendicular. If you see if we consider plane wave fronts, these are the plane wave fronts, and the energy movement will be in this direction. So these are the perpendicular. So if you see, statement number 3 is wrong and statement number 4 is correct. So our answer is 2 and 4, and it is option number D.